Hello everyone, today we are going through Bayes theorem, one of the important theorems on probability. So here first of all let's write conditional probability equations. We have a formula for conditional probability. Probability of A given B is equal to probability of A intersection B divided by probability of B. Right? Probability of B given A is equal to probability of A intersection B divided by probability of A. Now rewrite these equations. We get probability of A given B is equal to, see from this equation we will get probability of A intersection B is equal to probability of B given A into probability of A. Right? Now let's substitute this probability of A intersection B is equal to this one in first equation. We get probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Right? So it is called Bayes theorem. Okay, it is the formula for Bayes theorem. Now let's go through an example. Look at this example. A factory produces two products, product P and product Q, in a 70:30 mix. It is known that 5% of product P is defective while 8% of product Q is defective. If a randomly chosen defective product is found, what is the probability that it is product B? See here what are given? A factory produces two products, product P and product Q. So first of all let's write what is the probability of P. Probability of product P is 70 out of 100. Right? And probability of Q is equal to 30 out of 100. Okay. Then let D denote defective product. Okay. D is the event defective products. Next, see what is given. It is known that 5% of product P is defective. Is it probability of P given D or probability of D given P? Now see, look at this our question first of all. See what we have to find. We have to find if a randomly chosen defective product is found, what is the probability that it is product P? So what is the probability that it is product B? P. That is probability of P given that defective products have already occurred. So here we have to select that is products P from defective products. Okay. Therefore, here we have to find probability of P given D. Probability of P given D. Okay. So what is given? It is known that 5% of product P is defective. That is probability of D given P is given. Okay. That is probability of D given P is equal to 5%, that is 5 by 100. Now we have to find probability of P given D, right? That is probability of P given D. Here we will apply Bayes theorem. Probability of P given D is equal to probability of D given P into probability of P divided by probability of D. Okay. This one we know, right? We know probability of D given P. We know probability of P, and what is probability of D? We don't know what is probability of D. So here, see carefully, it's a sample space, okay? And products P, 70% product P and 30% product Q produced, okay? So here, see defective products can be P and Q, right? So here, defective products can be P and Q. Okay. Now, obviously, we can write this as P intersection D. Okay. It is the defective product, total defective products. Okay. So, here we can write it is P intersection D. Right. And what about this one? P intersection D. Sorry, Q intersection D. Right. It is P intersection D. It is Q intersection D. Therefore, here we can write probability of D probability of D is equal to probability of P intersection D plus probability of Q intersection D. Right? Okay. Now, we have a formula that is also from conditional probability. Probability of, see, this one can be written as probability of D given P, okay, probability of, or you can write P given D, but this one we have to find, therefore it is better to write probability of D given P, okay. So probability of D given P into probability of P, okay, plus this can be written as probability of Q D given Q into probability of Q, right. See, this one from our conditional probability formula, okay, because see here we know that probability of A given B is equal to probability of A intersection B divided by probability of B, right. That is, probability of A intersection B is equal to probability of A given B into probability of B. Okay, same formula applied here. That is, probability of P intersection D is equal to probability of D given P into probability of P plus probability of Q intersection D is equal to probability of D given Q into probability of Q. Okay, now let's substitute it here. That is, probability of D given P into probability of P divided by probability of D given P into probability of P plus probability of D given Q into probability of Q. Now we know all these terms, right? All these values. That is, probability of D given P 5 by 100 and probability of P 70 by 100. Probability of D given P, that is, yes, 5 by 100 and probability of P 70 by 100 plus probability of D given Q 8%, right? That is 8 by 100 and probability of Q 30 by 100. Now substitute the values and find. So it is the probability of P given D. Next is theorem of total probability. It is the foundation of Bayes theorem. Okay, now let's see what is total probability theorem says. Let E1, E2, etc. En be a partition of S, sample space S, and suppose that each of the events E1, E2, etc. En has non-zero probability of occurrence. Let A be any event associated with S, then probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus etc. plus probability of En into probability of A given En. If there are n events, it is the formula. Okay. If there are only 2 events, then the total probability formula is probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. See, for example, the probability of finding a defective mango is the summation of probability of finding defective mango from the different boxes of mangoes. See here, suppose there are only 3 boxes. Okay, so here we have to find the probability of defective mangoes. So here, suppose A is the defective mango. Okay, A denote defective mangoes. So probability of defective mango, probability of A is equal to probability of E1, that is probability of box 1, into probability of defective mangoes given that box 1, okay, plus probability of box 2 into probability of defective mangoes given that box 2 plus probability of box 3 into probability of defective mangoes given that box 3. Okay, so it is the total probability theorem. Now let's go through some more examples so that you will understand it quickly. Look at this very important question. Find the probability of drawing a 1 rupee coin from a purse with 2 compartments, one of which contains 3 50 paise coins and 2 1 rupee coins, and other contains 2 50 paise coins and 3 1 rupee coins. So there are 2 compartments in a purse. Okay, a purse has 2 compartments, and first compartment compartment has 3 50 paise coins and 2 1 rupee coins. And second compartment has 2 50 paise coins and 3 1 rupee coins. So here, first of all, let E1 be the event. First compartment of the purse is chosen. And E2 be the event. Second compartment of the purse is chosen. And what we have to find? Probability of drawing 1 rupee coin, right? So here let E be the event. 1 rupee coin is selected. 1 rupee coin is selected. Okay. So our 1 rupee coin is drawn from the purse. Okay. Now here, see, here we will apply a total probability theorem. We have to find probability of E, right? So probability of E is equal to, okay, now first of all let's write what is probability of E1. There are only 2 compartments in a purse, right? So here probability of first compartment of the purse is chosen is nothing but 1 out of 2, right? That is 1 by 2. And probability of E2 is also 1 by 2. Right? Okay. Next, let's apply total probability theorem to find probability of E. That is equal to probability of E1 into probability of E given E1 plus probability of E2 into probability of E given E2. Okay. Then what is probability of E given E1? Probability of E given E1. That is probability of 1 rupee coin is drawn from the first compartment. Okay. So how many coins are there? How many 1 rupee coins in first compartment? 2 coins, right? So out of 5. So here, that is how many coins are there? 5 coins, right? So here 1 by 5. Sorry, 2 by 5. 2 1 rupee coins in first compartment, right? And probability of, that is, see how 5, see 2 plus 3, 350 paise coins and 2 1 rupee coins. Therefore, there are total 5 coins in first compartment. Okay. Therefore, 2 out of 5. 2 divided by 5. And probability of E given E2. That is probability of 1 rupee coin is drawn from the second compartment. Okay. That is, here second compartment has how many 1 rupee coins? 3 1 rupee coins. And there are total 5 coins in compartment 2. Okay, second compartment. That is 2 plus 3, 5. So 3 by 5. Probability of E given E2 is 3 by 5. Therefore, probability of E is equal to probability of E1 1 by 2 into probability of E given E1 2 by 5 plus probability of E2 1 by 2 into 3 by 5. That is equal to, here 2 cancelled. So 1 by 5, or okay, we can write 2 by 10 plus 3 by 10, that is 5 by 10, that is equal to 1 by 2. So probability of 1 rupee coin is drawn from the purse is 1 by 2.